This video is about solving a system by graphing. So what is a system of equations? A system of equations is two or more equations with two or more unknowns or variables. All right? So if we have a system of equations, how then do we solve it? So what's the key? The key to solving a system is we're looking for the point of intersection. Now, there can be a couple of other types of solutions, but for the most part, a solution is going to be a point of intersection. All right, one technique for how we solve a system is to use graphing. So to solve a system by graphing, I'm going to follow these 4 steps that say write each equation in slope-intercept form. That makes it easier for us to graph. We're going to graph each line on the same coordinate plane. Then we're going to, hopefully our graphs are drawn well enough that we're going to be able to approximate the point of intersection. And then we're going to test that point or check that point to determine if it satisfies both. In order for it to be a solution, it has to satisfy both. In other words, when I plug x in and simplify, I should get that y value. So let's take a look at this first example. The first example here is both equations are already in slope-intercept form. So I'm ready to graph these two lines. I'm going to take my coordinate plane. There's the x-axis. There's the y-axis. The first graph I'm going to do in blue. So it has a y-intercept of -1. I'll mark that. And it has a slope that says go down 2, 1 to the right. So I go down 1, 2, I go to the right 1, and that gives me a point right about there. I then try to draw a sketch of this line to the best of my ability, keeping it straight. Now, drawing on the computer makes it a little bit harder for me. There are some tools that you could do to make it a little bit more exact. We're trying to see how we can solve this a little quickly. Okay, the second line, I'm going to go ahead and graph using green. So y equals 3x plus 4. I graph the y-intercept of 4. And then this slope says go up 3 and 1 to the right. So that gives me a point right there. Now remember, when you're graphing, you can go up and right for a positive slope, or I could go down 1, 2, 3, and 1 to the left. So if I came down 1, 2, 3, and 1 to the left, I'd have a point right around in there. Now this point right here, sorry, let me draw this line. This point that we graphed right here appears to be the place where maybe these two lines intersect each other. All right, so I'm going to identify that point. I'm going to identify the point as the point -1, 1. Now I need to check and see, does that work? So if I go to the first equation, I have y equals -2 times -1 minus 1. All right, so I literally am plugging in that x value. If I can get my pen working, there we go. I'm literally plugging in that x value to see if I get, remember this is x and this is y, to see if I get that y value. So I have y equals 2 minus 1 or y equals 1. That one checked off. So the first equation, we're good. The point -1, 1 works. Test the second equation. So I have y equals 3 times -1, same x value, plus 4, or y equals -3 plus 4, which again tells me y equals 1. That's the y value I'm supposed to get. The second equation is satisfied. Therefore, this must be my solution. That point is on both lines, and therefore our point of intersection. Now, what about an equation like this? Well, I'm going to take the first equation, x plus y equals 4. I'm going to put it into our preferred graphing method, which is slope-intercept form. So I'm going to subtract x, and I have y equals -1x plus 4. This is the line that I'm going to graph for the first equation. The second equation is 4x minus 3y equals 9. Again, I'm going to write this in slope-intercept form. So I would move the 4x, leaving me with negative 3y equals negative 4x plus 9. I would divide each piece by negative 3. All right, and that's going to leave me with y equals positive 4/3 x minus 3. This is the second line that I'm going to graph. I go to a coordinate plane. I draw the first line in blue, has a y-intercept of 4, 1, 2, 3, 4, and a slope that says down 1, 1 to the right. And I sketch that line to the best of my ability. The green graph has a y-intercept of negative 3, 1, 2, 3, and it has a slope of 4/3. So I'm going to go up 1, 2, 3, 4, and then 1, 2, 3. I'm thinking it's going to be there. I then estimate what I think that point is, and I'm pretty confident it's the point 3, 1. All right, so now what I need to do, though, is verify it. If I check it in the first one, I have y equals negative 1 times 3 plus 4, or y equals negative 3 plus 4, which means y is equal to 1. That's the y that I'm supposed to get when I plug in 3. Go to the second equation. Y equals 4/3 times 3 minus 3. Now 4/3 times 3, that's going to be 4 minus 3. And 4 minus 3 is 1. That checks off. Therefore, this must be my point of intersection, which is also known as the solution of the system. Hope this helps. Let me know if you have any questions.